right, as we begin today, practice exercise 101, and no calculators needed for this exercise. And we've been doing a lot of algebra in our practice exercises, but we're actually going to do some geometry in our practice exercise today. So working with complementary and supplementary angles. Go ahead and get started. Practice exercise 101.
Okay, my thought would have been, if they're this size, drove up and down the stairs and taken the stuff out and brought it up that way.
Well, it would have been easier to, I think, real hairy. So, 8 trips versus 10. So I'd rather just empty it here and put them in here. If that's what you said.
You know what, why don't you go these into this horse's room, actually? She's way ahead of herself.
The first one to finish would stand, unless you're right in front of the camera, and keep track of who finishes after. Finding complements, finding supplements, and then just writing out, is it acute, obtuse, or right? Take about another minute or so. All right, go put your pencils away if you would, please, and take out a pen. Pencils away, and take out a pen. And if you would exchange with the person behind you, person back, pass yours to the front. I'm going to go ahead and collect this one as a quiz grade. Hopefully, given that this was geometry, made this one a little bit easier for you. All right, sign your name as grader if you would. Next to where it says exercise 102, there at the bottom of exercise 101. And for the top row, you were simply writing the number of degrees in the complement of each of those given angles. Top row going across, your answers should be 67 degrees, 45 degrees, 34 degrees, 30 degrees, 71.5 degrees, 44.5 degrees. Yes, ma'am.
But they don't have the little degree symbol?
Did they forget on every single one?
Yes.
Let's do a -3 instead of like -1 each time. If it's like a random one here or there, let's do -1, but let's cap it at 3 points for forgetting degree symbols. Any other questions, top row? All right, next row. Finding the supplement of each of these angles going across 93 degrees, 58 degrees, 81.5 degrees, 45 degrees, 66 3/4 degrees, 84.5 degrees. Any questions on the second row? Yes, ma'am.
We only forgot 1 degree symbol.
So just take off -1. Yeah. All right, and then for the bottom row. Okay, so the top 2 rows were 6 points each. 6 points each for the top 2 rows. Figure the points off so far, because the bottom row is only 5 points each. Bottom row is only 5 points each. Bottom row, their answers should be in this order: acute, right, obtuse, obtuse, acute, acute. Again, acute, right, obtuse, obtuse, acute, acute. All right, those were 5 points each. All right, any grading questions? Figure the score, put it next to where it says exercise 101 and circle it if you would, please. Put the score next to where it says exercise 101 and circle it. And return to the owner. And Chris, you were the one who forgot all the degree
That's
symbols.
perfect, except for the degree
Perfect other than degree symbols. All right, so I'm going to hold that. If no one else was perfect, I'll still give it to you. Second was Ethan. Did you get 100?
Jamie was perfect.
Let's see, third. Oh, you were second. You were, what am I talking about? You were second. Did you get 100? You did not. You were third. Fourth?
99.
Bruh.
So more perfect than but Jamie was fifth, and you were perfect? Oh, okay. All right, so it actually would have gone to him ahead of you since his score was higher, but we did get 1 perfect, and then almost perfect, other than the degree symbols.
Third place.
All right, any other A's? Any other A's? Maybe just missed one thing? How about B's? Made a B? Are there any questions on this exercise? Any questions? Is that a question, Genesis? You sure? All right. Go and pass those forward if you would, please. And take out your homework handouts. Homework handouts out. And let's go to review over our area formulas because we have been adding to our list little bits at a time as we've gone. Don't want to forget where we started, though, was the rectangle. And what is that formula for the area of a rectangle, Kendall? I'm sorry? Good, R equals BH. From there we went to the square, Genesis.
Square equals side squared.
All right, and then from thence to the parallelogram.
PL equals BH.
And thither to the triangle.
T equals 1/2 BH.
And then to the trapezoid. In yesterday's lesson, you got a chance to use it a little bit in your homework last night, but we didn't spend a lot of time with it. There were actually 2 formulas. Do you remember one of them, Chris?
Isn't one of them trapezoid equals, like, B or P something? I had it written down.
Can you help him? Quentin, do you remember?
H times B plus C prime.
Really close. 1/2. H times B plus B prime. And then there was another one. Audrey, do you remember the other formula for the area of a trapezoid? Anyone?
Is it base median, BM?
Close.
Trapezoid equals
HM, altitude, times median. So remember that half the sum of the bases is the median, so the H stays and everything else becomes M for median. So these were our formulas, and of course if I wanted to compare two rectangles or two parallelograms or triangles, you know, R is to R prime is B, H is to B prime, H prime, and so forth. Let's go and take a look at the handouts. Hold them up if you would so that I can see that they are completed. Hold them up so that I can see that they are completed. All right, got homework pass here. All right, make sure it didn't expire yet. Just kidding. All right, let's go and take a look at the homework handout together. Do you have your handout still, Genesis? All right, so if you want to get that out and you kind of work it along with us here, and of course if you had any questions, be sure to ask. For number one, we were finding the area of a rectangle given sides of 7.8 centimeters on altitude and a base of 15 centimeters. What did you get for your answer, Ethan?
117 centimeters squared.
117 centimeters squared. How many the same answer? Any questions? Number two, next to it, you were given a parallelogram. You were told the area was 72 inches squared. You were told the base was 16 inches. I was asking for the altitude, Kendall.
4.5 inches.
4.5 inches is correct. How many had 4.5 inches or 4.5 inches since it worked out evenly? All right, number three, given a triangle, told that the area was 44 inches squared, told that the altitude was 8 inches, asked for the base, Audrey. 11 inches, good. Had to use that 1/2 BH formula. How many had 11 inches? All right, any questions at all on that one? All right, go to the next one. This one's the trapezoid. You notice that two sides are not parallel. Two sides appear to be parallel. You're told that one of the bases is 5 inches, the other 9 inches, and you're also told that the altitude is 5 inches. So for this, we're going to go with our formula here, TR equals 1/2 H, which is 5 inches, times B plus B prime, which of course would be 5 inches plus 9 inches. Now, frankly, most of the time, I'd expect you to just add them in your head, right? I mean, if we can't do 5 plus 9, we're in trouble. All right, so 14 inches. And then the idea would be, remember, if you can, take half of one of these. In this case, I can take half of the 14 to get 7. Can you take half of both of them? No. This is only 1, 2, so we can only cancel with one of these other numbers, right? And so that should give us an area of, Quentin?
35 inches squared.
35 inches squared. How many had that for number 4? You plugged into the formula correctly. All right, again, start by writing out the formula. Plug in the numbers where they would go. Again, B and B prime are interchangeable, but you're adding them, and addition's commutative, so it doesn't matter as long as we get the altitude correct, and don't forget the half. Questions at all on the trapezoid? Is your first time doing one?
Forgot to have.
Forgot the half? All right. Any other questions, comments on the trapezoid? Again, that's not a figure we'd worked on before. All the others we had. Questions? All right. Let's take a look at number 5, and another trapezoid. You can tell two sides parallel, two sides not. And there were a couple of midpoints of the legs and a line drawn joining those midpoints. Class, what do we call that line?
Median.
The median. And the median was listed as being 12 inches. And then the altitude, the perpendicular, was listed as being 5 inches. So we go to the formula here, TR equals HM, altitude times median. You just multiply them to get, Chris. 60
inches squared.
Inches squared is correct. How many had 60 inches squared for number 5? Any questions on number 5? Again, Genesis, any questions 4 or 5 especially? Feel like you understand them even though you didn't take time to do them. All right, number 6 is where things start to get a little more interesting because there's a 30-degree angle. And as soon as you see a 30-degree angle, class, you should be thinking
30, 60, 90.
30, 60, 90. And so I was given a 10-inch base and a 6-inch side. My drawing is less to scale than the drawing on the handout. And a 30-degree angle here. And I was asking for the area of the parallelogram. What do we need to do first here, Jamie?
We need to find the altitude.
You've got to find the altitude, because to find the area, base times altitude, you need the base, check, and we need the altitude. And I would specifically recommend drawing it right here at the vertex to form a...
Right. 30, 60, 90.
The 30, 60, 90 we were already expecting when we saw the 30-degree angle. If you do, Jamie, how would I label the various pieces of the 30, 60, 90?
The side across from the 90 angle is 2x. The side across from the 30 is x times the square root of 3.
Ooh, across from the 30. The little angle's the 30. The little side is the x. And so down here, this part of the base would actually be the
X times the square root of 3.
which actually works pretty nicely for us because it makes our numbers easier, right? It means that the altitude is just,
2,
well, 6 inches is 2x. So x would be
3.
3 inches. Well, there's my altitude, there's my base. If the area of a parallelogram is base times altitude, Jamie, what should we have gotten for the area?
3 times the square root of 3.
I've got an altitude of 3, and I've got a base of 10.
Oh, 30.
30, right? 3 inches altitude times 10-inch base will give us the 30 inches squared. How many had 30 inches squared? How many had 30 times the square root of 3 inches squared? And you put the x squared of 3 across from the 30. Don't do that. X is across from 30. Questions on number 6? All right, number 7, you were given a square, all sides equal, and there's a right angle. And you were told the area was 48 feet, and I asked for the length of one side. What formula do we use for the area of a square, Chris?
Square equals s squared.
And if I were told that a side was 48, class, I'd put that right here and I'd square it. But I was told that the area was 48 feet squared. And I was asking for a side. What do we have to do here, Ethan?
This is where I asked kind of.
I know that s squared is 48 feet squared, but I just want to know s. I don't want s squared, I want s. What do I do to get rid of the little exponent? Chris?
Square both sides.
Ooh, that would give me an s to the 4th. I don't know, that makes the problem worse, not better.
What I did was I squared the 48.
Oh!
Square root, took the square root of 48.
Oh, square root! Yes, you do take the square root. Because the square root and the square would cancel to give you the s. Just like in the Pythagorean theorem class, when you put your a squared and b squared here, when you want just c, you end by taking the square root. Same thing here with the s. Take the square root. Oh,
that's what I meant.
That comes out to a crazy decimal though, right? Almost comes out to 7, right? It'd be 6.9 something-ish, but we don't do crazy decimals, do we? We never round anything in this class, do we? So what do I do with the square root of 48? Back to Ethan.
4 goes into 14 times.
All right, back to 3rd grade. 4 times 12 equals 48. All right, but that could factor as well, right? I could factor the 12 even.
1,
So I can take the square root of the 4
2,
and the square root of this 4,
2,
put those together to get a,
4 times square root.
and then also take the square root of feet squared, feet. And each side of the square is 4 times the square root of 3 feet. How many had that answer?
I did
for number 7.
16 and 3.
16 and 3 is a lot quicker, but hey, it's okay. If you see the 4, that's fine. Go ahead and take what you see, and you can work your way down
It
later.
doesn't matter how you get the right answer.
It doesn't, though I prefer 16 times 3 because it's quicker and I'm lazy. But it works. All right, questions on 7. Oh, we don't do that here. All right, and then number 8, another parallelogram like number 6, but this time we have a 60-degree angle. Now that changes things. Because if you got a 60-degree angle, what's the side opposite the 60, class? X times the square root of 3. That means up here's the little 30. What's opposite the 30? And of course, opposite the 90 is the hypotenuse, we would call 2x. Now, we were told that this base was 12 feet, and that's not the x portion, that's the whole base is 12 feet. And then we were told that right here, this side was 4 feet. Of course, we had the 60-degree angle in between them. And again, we were asking for the area. Well, again, if 4 feet is 2x, then class x is 2, which means the altitude is 2 times the square root of 3 feet. There's the altitude, there's the base. PL equals BH. We're going to multiply them to get, class?
24 times the square root of 3.
24 times the square root of 3 feet squared. How many had that answer for number 8? All right, do we see the difference? If you're opposite of 60, that's the x squared of 3. Opposite of 30, that's just x. What about opposite of 45?
X.
Right, just plain x, because opposite of 90 would be the x squared of 2. Okay, keep all those special triangles straight in your mind. Questions on that? All right, let's take a look at number 9 now. And it says the areas of 2 rectangles are in the ratio of 5 to 7. Base and altitude of the first rectangle are 10 inches, 9 inches. Altitude of the second rectangle is 6 inches. Find its base. How do we set this up, Genesis?
R over R prime equals BH over B prime H prime.
Good. R is to R prime is BH is to B prime H prime. And we see all the numbers in there. How would I plug those numbers in?
I'm gonna do 5 over 7 equals 10 inches times 9 inches over B prime times 6 inches.
Perfect. Plug everything in where it goes. And we could just straight up cross multiply, or we could do some canceling. What do you want to do here, Genesis?
Cancel the inches.
Okay, let's cancel the inches. Now, not all the inches cancel, but those two do, right?
The 9 and the 6.
Okay, to get
3 and 2. And 2 and 10. 1 and 5.
all right, so if we wanted to, Genesis, maybe with this point we will rewrite the mess a little bit and say 5 is to 7 as what's left in the top now?
15 is to B prime.
Right, 15 inches is to, and the B prime times 1 is all that's left. Now we're ready to go ahead and cross multiply.
5 B prime equals 105.
And then when we divide away the 5, we'll get B prime equals 21 inches. How many had 21 inches for number 9? Questions on the handout? Any questions at all? Turn to page 243 in your textbook. You can set your handouts aside. Or maybe flip it over and use the back side and do some work here. On page 243, you see the trapezoid theorem and trapezoid corollary that we copied out yesterday at the end of the hour. You'll also notice there are 3 exercises for you. I want you to write in a 4th in your textbook. So you see how there's a spot for a 4th and they never actually put it in there? Yeah, delinquents. I'm going to give them the 4th. All right, so number 4, go ahead and write this problem down. They're on page 243, quickly turning. Should be there by now. Page 243. Write in problem number 4. The median of a trapezoid. The median of a trapezoid is 15 centimeters. The median of a trapezoid is 15 centimeters. The altitude is 7 centimeters. The altitude is 7 centimeters. Find the area. Find the area. At your seats, if you would, do 1 through 4. They're on page 243. I'm going to do numbers 1 through 4 on page 243. Practicing with the formula for the area of a trapezoid. Yes, sir.
The bases of a trapezoid are 5 and 4 feet, 3 and 10. Its altitude is 2 feet and 4 inches.
Oh, yeah, we got some compound units going on here, don't we? Can we really work with compound units much? No. Now, you can add compound units. You can add 5 feet, 4 inches, 3 feet, 10 inches, 2 feet, 4, but you can't multiply them, can you? So what I would suggest, convert it all to inches. Remembering that there are how many inches in a foot? 12. Convert it all to inches. Sorry?
Where'd you get 18 feet?
You mean 8 feet, 14 inches?
Yeah, 8 feet.
I added the two bases together. Remember I said we'll normally do that step in our head?
Yeah.
Though technically you'd normally put 9 feet 2 inches. You wouldn't normally leave it because we're about to change it all inches anyway, right?
I honestly think it's easier if you don't add them first.
Maybe so. Maybe so.
That's just personal preference though.
All right, let's go and take a look at these together. I went ahead and added the two bases together to get 8 feet 14 inches, or you might have gotten 9 feet 2 inches, but I converted them all to just inches. Get 110 inches here. If you decided to change them to inches first, that would be, 64 inches and 46 inches, which adds to 110 inches. 2 feet 4 inches becomes 28 inches. Remember, multiply the feet times 12 and then tack on the extras. I went ahead and took half of 14, multiplied 14 inches by 110 inches to get 1,540 inches squared. How many have this answer for the first one? Excellent. On the next one, we knew the two bases would add to 22 inches. We also knew the area was 55 inches squared. I took half of the 22 to get 11, and then divided away the 11 inches from both sides to get 5 inches for the altitude. How many got the same answer? All right, questions on that one? On this next one, there's a couple ways you could go here. I knew the area, 276. I knew the altitude was 12. I knew one of the bases was B, but the other would be 14 or 14 and B prime, up to you. I went in and took half of the 12 to get 6 and then distributed the 6 to get 6b inches plus 84 inches squared. I then subtracted the 84 to get 192, divided away the 6 inches to get 32 inches. The other way you could have done it was to go ahead and cancel to get 276, I'm going to drop the units here, equals 6 times b plus 14. You could have divided the 6 away first. Rather than distributing the 6, just get rid of the 6 entirely. Now you won't need the parentheses anymore. That would get us, what is that, 46 is equal to b plus 14. And then you could have subtracted the 14 at the back end. Still would have gotten 32 inches. How many got, either way, 32 inches for the other base?
Something completely different, but I got it.
Something completely different. Did you multiply both sides by 2 by any chance to try to knock out the half? What did you do?
So what I did is I ended up dividing 276 by 12.
Okay, and that gave you 23?
Yep.
Okay.
And then I did the b. I'm pretty sure that's what I did. I did the b plus the b, and that gave, or I did b, and then I minus that away, and then I did some other stuff. I don't know how I got the right answer, to be honest with you. But
Okay, do you see algebraically what we
yeah.
should have probably done here?
yeah,
All right.
I didn't work it out on my paper, so I just did all of
Okay, questions? Any other questions? On the last one, pretty straightforward. You knew the altitude and the median, multiplied 105 centimeters squared. Good to go on that one? All right, questions on that one? Any questions at all on trapezoids? Again, because of the binomial, the math on the trapezoid can be more challenging, especially if you're only given one of them. Just be careful. The trapezoid tends to be more difficult because of the binomial, also because of the half, like the triangle has the half. So some little things make the trapezoid more challenging. Questions on the trapezoid? All right, turn over, if you would, in your textbooks to page 244. So just flip the page over, and I want you to read exercise number 1 for us, if you would, Quentin.
Prove that the area of a right triangle is equal to 1/2 part of the 2 legs.
Prove that the area of a right triangle equals half the product of the 2 legs. Now consider for a moment a right triangle. What is the area of any triangle, class? What have we proven? 1/2 BH, right? So if I drew this altitude right here, then half the product of the altitude and the base. Now in this case, the base is called the hypotenuse. But you realize any geometric figure may be freely moved through space without any change in form or size, right? Why not flip the triangle like this? You can always rotate a triangle, right? You can always rotate any figure. Now, what do we call the base? Leg. What do we call the other? What do we call the altitude? Leg. Because they're perpendicular, if one is the base, the other is the altitude. And so, we get this formula. For a right triangle, we could just say the area equals leg times leg. And if you would, go ahead and I've actually been wanting you to do this for a while, I keep forgetting. Go and turn to your class notes section of your notebook. We're going to get a page of all our area formulas. Let's add this to our list of area formulas. Now, Genesis has already been doing this on her own, which is great. So Genesis just needs to add this 1. But for the rest of us, let's go ahead and get our list down. R equals BH. R is to R prime is BH is to B prime H prime. SQ equals S squared. PL equals BH. T equals 1/2 BH. We had TR equals 1/2 H times B plus B prime. TR equals H times M. And then T sub RT equals 1/2 L sub 1 L sub 2. So if you go and get these formulas in the class notes section of your notebook, you just put area formulas maybe at the top of the page or at the top of the section on the page. And this will make it, I think, easier for you to study those formulas if we have them all in one spot, rather than perusing the entire theorems and corollaries section. Well, I guess only the recent theorems and corollaries, but still. Make it a little bit more concise for you. And we're going to add one more here in just a moment as well. give you a moment to finish getting these copied down again. This just keeps all the formulas in one nice, easy to study place. Now, we understand we could also say PL is to PL prime as BH is to B prime H prime, but if you remember that's true of the rectangles, I think you'll remember that's true of the parallelograms. We could say T is to T prime as BH is to B prime H prime. Again, if you remember that's true of the parallelogram and rectangle, of course it's got to be true of the triangles as well. So yeah, just in general, I don't know that we necessarily need to copy those down. I guess if you really wanted to, you could. Take a look at number 4 now on the same page, page 244, and read this one for us, Genesis.
Prove that if the diagonals of the quadrilateral are perpendicular to each other, the area of the quadrilateral equals 1/2 the product of the two diagonals.
Huh. If the diagonals of a quadrilateral are perpendicular to each other, which quadrilateral has perpendicular diagonals? True to specific. Something less specific than even a square. But you're right, a square does have perpendicular diagonals. Rectangle does not. It has equal diagonals, but they're not necessarily perpendicular. Parallelograms diagonals will bisect, but they are not necessarily perpendicular. Ooh, we've forgotten. A rhombus has perpendicular diagonals. Now, there are other quadrilaterals, to be fair, as well, right? Like, for instance, if you were to take like a kite shape, those diagonals may be perpendicular as well, right? So just because diagonals are perpendicular doesn't mean it has to be a rhombus, but the rhombus is the figure we're most familiar with here. It says prove that if the diagonals are perpendicular, which would include rhombuses or rhombi? Anyway, rhombuses, that the area equals half the product of the two diagonals. Well, think about it. If the diagonals are perpendicular to each other, then what I would get is I'd actually get 4 right triangles, wouldn't I? You could also think of this as 2 bigger triangles as well, couldn't you? Right? Even in fact, if the diagonals were perpendicular, even if 1/2 was longer. Okay, so it's not a rhombus, but the diagonals are still perpendicular. Do you see that? It's not even a kite anymore, at least not one that I think would fly real well, or at least not one that would look good if it were flying. But you get the idea, right? We have 2 triangles. Now notice, this could be looked at as the base of one of the triangles. And this piece, which we could call half diagonal 1, we could call this whole thing diagonal 2. The area of this triangle 1 is half of its base, which is diagonal 2, and its altitude, which is half of diagonal 1, correct? If we look at this triangle, though, its base could also be considered D2, and its piece could be considered the other half of diagonal 1. Now, technically, they may not be perfect halves even, but whatever portion of the one and the portion of the other, maybe call it X and Y, we know together they're going to add up to D1. In the case of a rhombus, they would actually bisect, so we'll roll with the half D1 there. But that means triangle 2 is equal to half the base, diagonal 2, times the altitude, the other half, or maybe the other piece of diagonal 1. But we know that the entire quadrilateral equals the sum of the 2 triangles, correct? So that the area of the quadrilateral is going to be half diagonal 2 times half diagonal 1 plus half diagonal 2 times the other half, or piece of diagonal 1. You notice there's a common half and a common D2. So in parentheses, we can be left with half diagonal 1 plus half diagonal 1, which if they're true halves adds up to a whole diagonal 1. If you just say pieces, the 2 pieces still add up to the whole diagonal 1, so that the area is equal to half the product of the diagonals. Now, again, that works for any quadrilateral with perpendicular diagonals. But for us, since the only one of those that has a special name is the rhombus, we're going to add this formula. RH for rhombus equals half diagonal 1, diagonal 2. Again, this is technically true for any quadrilateral with perpendicular diagonals, but particularly true of the rhombus in this case, since we know it to be a special quadrilateral that has perpendicular diagonals. So we now have a rhombus formula. RH equals 1/2 D1 D2, which means, by the way, Quentin, that a square's area could be found half diagonal 1 diagonal 2, couldn't it? Because a square is a rhombus. Any questions on that? Let's take a look at some more problems together now. We'll go right up there to number 3, but we're going to approach number 3 differently than we normally would. Go ahead and read number 3 for us, if you would, Audrey. Now, normally, class, if we're finding a square, normally we would use what formula? SQ equals S squared. And since they're so kind as to tell us the side is 12 inches, where would I plug in the 12 inches, class? For the S, right? So SQ would equal 12 inches. So normally, we would just square the 12, class, and we would get 144 inches squared. But we're not going to do it that way. We're going to do it Quentin's way. Because Quentin says that a square is a rhombus, and he's right. So let's consider for a moment a square with 12-inch sides. How long would the diagonal be of a square with 12-inch sides, Quentin?
12 times square root of 2.
Right, 12 times the square root of 2 inches. What about the other diagonal, Quentin?
12 times square root of 2.
Right, because a square is also a rectangle, and rectangles have equal diagonals, so this is also 12 times the square root of 2 inches, not inches squared, right? And so since a square is a rhombus, we could say that RH equals, class, 1/2 D1 D2. Again, RH equals 1/2 D1 D2. So I could say that the area of the rhombus, it's a square, but it's also a rhombus, is half of 12 times the square root of 2 inches times 12 times the square root of 2 inches. Where I could, of course, knock out a half with maybe a 12 to get a 6. And now we'll multiply. 6 times the square root of 2 times 12 times the square root of 2 gives us what? 72, careful, times the square root of 4. Remember, when you multiply radicals, you multiply the radicands. Square root of 3 times square root of 7, square root of 21. Square root of 2 times square root of 2, square root of 4. And inches times inches, of course, inches squared. Of course, the square root of 4, class, is 2 times the 72 gives us 144 inches squared. Now, granted, it would have been a lot quicker to go with the S squared, but I wanted to show we could have used the rhombus formula there. Questions on that? All right, let's drop down now to number 11. Number 11, and work that at your seats. They give us the area of a rhombus, and they give us one diagonal. They want the other diagonal. Go and do number 11 now. Bracken, can you shut the door, please? All right, check your work. Did you get 24 inches for your answer? All right, any questions on that formula? Again, like always, if you're given the area, make sure you plug it in for where the capital letters are and solve for the other piece. How about number 12? Read number 12 for us, if you would. Kendall.
Okay, so a triangle is 18.6 inches and the altitude is 12.4 inches. Find the side of the square whose area equals that of the triangle.
Whoa. Read that last sentence again.
Find the side of the square whose area equals that of the triangle.
It was all good. It's just base of triangle, altitude. It's like, yay, find the area of the triangle. No! Find the side of a square whose area equals that of the triangle. what are we gonna have to do here?
Find the area of the triangle and then.
Still start with the area of the triangle, right? So pretty straightforward, area of the triangle, half BH, they tell us the base, they tell us the altitude, plug in the numbers, still start by finding the area. Still do what your gut initially said to do. And I can't do that in my head, so I'm gonna cheat and get a calculator out too. All right, what do we get? Ew.
115.
Yeah, 115.32 square inches. That's the area of the triangle. They didn't ask for that. What'd they ask for?
The side of a square.
The side of some square, but it's not just any square. This is a square that is,
Its area equals that of the triangle.
its area equals that of the triangle. The square in question equals the triangle. They are equal figures. They have the same number of square units, the same area. Which means if a triangle equals a square, then we could say that a half BH, which is a triangle's area, equals S squared, right? Which is what the square is. So we could say that a half of 18.6 times 12.4 equals S squared, which means we could say that the S squared, area of a square, equals the 115.32 inches squared that is the triangle. So how would we find a side of the square?
Take square root.
Take the square root. Please come out evenly.
It
No, it doesn't. Okay. I was worried when I saw that too. I was like, oh. Let's see. 115.32.
comes out really bad.
It does come out awful, doesn't it? Let's see. We know it's going to come out to plain old inches. Let's go and do that. Let's see. Is there a square in 115.32? Something we can divide out? I'm looking at the last two digits. I know I can divide out a 4. Let's divide that by 4. All right, so this comes out to 4 times 28.83. There's got to be another square in there somewhere. But 9 ain't one of them. 49 maybe? I don't know, try dividing that by 49, see what happens. No, don't do that. Let's see, 28.83, 121? I'm trying to think of weird numbers.
No.
I don't know, maybe that's the best we can do is 2 times the square root of 28.83 inches. Oh man, such a nasty looking number. But anyway, do you understand the premise? Because we're going to be in working problems in our next lesson where we'll have one figure equal to another one. And we've got to be able to work between the formulas, questions on that. I hate the way the numbers worked out though. All right, your homework for this evening is to complete handout 12. Handout 12, which I'll be passing out to you. But if you're watching on YouTube, again, go back to your second semester geometry handouts and do handout 12 for homework this evening. Have a wonderful weekend and, of course, a wonderful rest of your day. And you are dismissed.